So in this video, we're going to be taking the idea of trigonometric ratios of any angle and extending it to what we call the unit circle. So I will ask you to recall with me the equation of a circle that is centered at the origin with a particular radius. Oh boy, yep, that's definitely kind of a circle. The equation of a circle centered at the origin of radius r is x squared plus y squared is equal to r squared. Now what I'd like to do is draw an angle in standard position. Angle in standard position. You'll notice that for any angle in standard position, we can call that theta, it will intersect with this circle at exactly 1 point. And for lack of creativity, I'm going to refer to this point of intersection as AB. Now with that in mind, I can also draw in the reference triangle for this circle and label a couple of sides. The horizontal side, of course, being A, vertical side being B, and the hypotenuse, as it were, being R. Now, this is why we went into the naming scheme of using R for the hypotenuse, is because really R is referring to the radius of a circle. Now, with that in mind, the introduction of the unit circle. Anytime the word unit comes up in a mathematical sense, the number 1 is going to show up as well. Now, in this sense, the unit circle is going to be a circle with the center at the origin of radius 1. Now, essentially, the way that I can create something like this is through the use of a horizontal and vertical shrink by a factor of r. So if I take, ignoring the advice of every mathematician I've ever talked to ever, always draw the circle first. Holy crap, you know what? That's not going particularly well either. I'm going to try one more time. You know what? It's good enough. So if I were to take this original circle and scale everything down by a factor of r, I would arrive at the following. So scaling everything down by a factor of r, the radius that used to be r is now r divided by r, and that'll be 1. In the reference triangle, the horizontal side was a, now it's going to be a over r. And the vertical side was b, now it is b over r. Now that means that the ordered pair that we have associated with this is a over r and b over r. However, taking a look back at the original circle that we had, a over r for the x-coordinate is the adjacent side over the hypotenuse. So when we say a over r, what we're really saying is that that is the cosine of the given angle. And for the y-coordinate of b over r, that is the opposite side over the hypotenuse. That would be the sine of theta. So with that in mind, here's a little definition for you. Given an angle in standard position, given an angle in standard position, if the point of intersection between theta and the unit circle is the ordered pair xy, then the x-coordinate is going to be the cosine of theta, and the y-coordinate is going to be the sine of theta. Now with this in mind, we can also define our other trigonometric functions. The tangent of theta is supposed to be the sine of theta divided by the cosine of theta. Sine divided by cosine would be y over x. The cotangent of theta should be the reciprocal of that. That'll be x over y. The secant is supposed to be the reciprocal of the cosine. The reciprocal of the cosine will be 1 over x. And the cosecant of theta is supposed to be the reciprocal of the sine of theta. So that'll be 1 over y. So with that in mind, an example. For this example, we are going to define a point, and that point is going to be negative 5/13 and positive 12/13. So x value is negative, y value is positive. It'll look something along these lines if we were to draw this. So part A for this, verify this point, is on the unit circle. To verify that a point is on the unit circle, we will need to verify that x squared plus y squared is equal to 1. So we'll perform a calculation of x squared plus y squared. That'll be negative 5/13 quantity squared plus 12/13 quantity squared. Squaring each of these will give us positive 25 over 169 and 144 over 169. Adding these two numerators together, since we already have a common denominator, will give us 169 over 169. That reduces down to 1, which verifies that x squared plus y squared is equal to 1, so it's on the unit circle. Now for part B, we'll say suppose theta, an angle in standard position, passes through this point. Find the 6 trigonometric ratios of theta. Find all trigonometric ratios of theta. So what we can do immediately is think to ourselves, because this is a point on the unit circle, the x-coordinate is going to be the cosine of theta, and the y-coordinate is going to be the sine of theta. So with that in mind, sine of theta we just labeled as being 12/13, and the cosine of theta we just labeled as being negative 5/13. Now for the other three, we'll have to make use of some fundamental identities. Tangent of theta is supposed to be the sine of theta over the cosine of theta, which will be 12/13 divided by negative 5/13. This simplifies quite nicely because the 13ths will cancel out and we'll be left with negative 12/5. The cotangent should be the reciprocal of what we just got, so 1 over the tangent, which is really just a fancy way of saying flip the top and the bottom, and that'll be negative 5 over 12. Do the same thing for the secant. Secant is supposed to be the reciprocal of the cosine, which again is just a fancy way of saying go ahead and flip the top and the bottom. That'll be negative 13 over 5. And finally for the cosecant of theta, that'll be the reciprocal of the sine of theta. And from that we will get 13/12.